In this video, I'll be helping you with the ALEKS problem type called adding rational expressions with denominators AX and BX advanced. In this example, we're subtracting these two expressions, and we know that anytime we're adding and subtracting fractions, we'll need to get a common denominator. These two fractions do have a common d in the denominator, but we'll need to do some work on the 6 and 8 to get a common denominator. To identify our lowest common denominator, we know that it will have the d. And between the 6 and the 8, we look for the lowest common multiple, and 24 is the smallest multiple of both 6 and 8, so my lowest common denominator will be 24d. And I can tell here I'll need to rewrite each of these expressions as being over 24d. Starting with the first fraction, I have a 6d. I would need to multiply that by 4 to get a 24d. And if I multiply the denominator by 4, I must also multiply the numerator by 4. I'll go ahead and distribute here. 4 times 5d is 20d. And 4 times 3 is plus 12. In the second fraction, to get that 24d, I would need to multiply the denominator here by 3. That would give me 24d, but I also need to multiply the numerator by 3. 3 times 2d would give me 6d. 3 times a plus 1, a plus 3. At this stage, we've rewritten with a common denominator, and I know that once I have a common denominator, I'll keep that denominator, and from here I can add and subtract the like terms in the numerator. But I will need to be careful, since this is subtraction, to recall that this subtraction will apply to everything behind it. And one way I can do that is by putting everything behind that subtraction in parentheses. And then to remove those parentheses, I know that I'll have to distribute. So the first part of the expression will stay the same, but distributing that negative would give me a minus 6d, and distributing the negative to the plus 3, a minus 3. From here, our denominator is unchanged, but we can start to combine like terms in the numerator. 20d minus 6d would be 14d, and 12 minus 3 would be 9. And when I have these rational expressions, I always want to check to see if any factors will cancel. There's nothing that factors out of the numerator, so nothing to cancel. This would be our solution in its simplest form.